All right, tonight we're going to be talking about our types of chemical reactions. And a chemical reaction occurs because it's trying to produce a more stable arrangement of electrons in the atom, ion, or molecule. And what you have reactants or reactant, you could have one, that react with each other to produce your products, okay? Products are always your ending, so you always need to write them on the right. It's like we always read left to right in English. The products are what you are produced, or what are produced, so it will always be at the end, and so it'll be always on the furthest right. And what is it going to be right of? It's going to be to the right of the arrow. The arrow always goes from left to right, okay? So reactants are always on the left, products are always on the right of the arrow. And there are a few signs of chemical change that we have talked about briefly before, and these are all signs that something has happened, where they're actually rearranging the bonds that are involved in the chemicals, but they're not a guarantee. The only guaranteed sign is the precipitate formation, which we'll get into. Okay, so the first sign is if you see a formation of a gas. Now, sometimes it can be deceiving because you'll see boiling, and even though boiling is a production of a gas, it is not actually a chemical change. Instead, it is physical because you are not rearranging any of the bonds. So for example, if you're boiling water, you still have H bonded to an O, and then that O bonded to another H. It's just whether it's in the liquid or the gaseous form. So, but if you do see bubbling, then that is a sign of a chemical change. Typically, if you see more than one of these, it tends to be more and more of that a chemical change actually did occur. Now, you do need to have this word memorized. And a precipitate, everybody always thinks it's about water and precipitation, and it's not. What it is when you have two liquids or aqueous solutions, okay, that come together, and you actually are able to form some sort of solid from it. And the other one would be, the other product would typically be an aqueous. Now, the solid that you're going to be forming is not like when you combine, let's say, like one liquid and another liquid, and you get like an eraser. Which instead you're going to get is it's probably going to be more foggy or cloudy. And if we had really, really fine filter paper and we poured that solution now in the product side through that, we would have a powder on top of that filter paper, and the liquid or that aqueous thing would have gone all the way through. So it's more of like a fine powder. Typically you might not even think it would be a solid. It's just some sort of, it becomes muddy, I guess you would see it as. And that would be a precipitate, is that solid that was formed. Change in color, so let's say it goes from blue to green, that would be a chemical change. Change in temperature, and that can be either going up or that could be going down. So it can either get hotter or colder. If you see light being emitted, such as during a firework, that is a sign of a chemical change. If you notice that there's a change in smell or taste, though we would try not to taste in this class, that would be probably a no-no. But if you notice that there is a different one, then there is a chemical change probably going on. And the last one is that it is irreversible. So you cannot get it back what you started with relatively easily. Alright, so there are 5 types of chemical reactions that you are going to be expected to know. The first one is the biggie, and that is combustion. And when you think of combustion, what everybody typically thinks of is flames or fires. And what do you need in order for that to occur? Well, you need oxygen. Okay, so everybody seems to know that. Now, what is a combustion reaction? A combustion reaction is when you have a hydrocarbon, and from now on, a hydrocarbon has a hydrogen and carbon combination. It can also sometimes have a different element. Typically in this class, it will be possibly an oxygen, though it doesn't need that. In order for a hydrocarbon, it to be a hydrocarbon, though, you do need that hydrogen and that carbon, though any other element can or may not be there. And what happens is that they react with oxygen, and you will always, always, always produce carbon dioxide and water. So any combustion reaction that we run across, your products 100% of the time will be carbon dioxide and water. So the general form that we'll be asking you to know is that, oh, I see this hydrocarbon. These X's and the Y's just represent any number. So I could have CH4, or I could have C2H6. And the X just changes. So in this first one, the X was 1, in this one it is 2. But notice that it is a hydrocarbon, and we're adding oxygen, and the products are carbon dioxide and water. When you're predicting the products, or you're going to be expected to predict products, what you're going to look for is, do I have a hydrocarbon, and am I reacting with oxygen? If I am, then I guarantee know that my products are going to be carbon dioxide and water. I don't even need to think about it. The next type of reaction that you're going to need to know is synthesis. And what I always think of with synthesis is a synthesizer in music. And what a synthesizer does is it brings all the instruments together. And that's what a synthesis reaction does, is basically you have 2 or more, so you could have 2, 3, 4, 5, whatever, substances, so they could be elements or compounds. And what they do is they react together to form only one compound. So that's the key. It's 2 or more substances that form one compound, and that would be a synthesis reaction. So your general form is an A, so that could be an element or a compound, combining with B to make an element or compound. But the key is that you are only producing one compound at the end. When we expect you to predict the products, meaning we will give you both reactants, we will give it to you in the form of an element. So E stands for element in this class for right now. An element plus another element, okay? And what we're going to expect you to do is smush them together to make a compound. So C in this class right now represents a compound. The third type is the exact opposite of a synthesis reaction, and that would be a decomposition reaction. So when I think of a decomposition reaction, I think of something decomposing on the side of the road. And what happens when something is decomposing on the side of the road? Well, it's breaking apart. And that's exactly what a decomposition reaction does. It's where a single reactant, okay, which will be a compound, and it's broken up into 2 or more products. So it could be 2, 3, 4, 5, 6 products, whatever. But what you want to look for is key to identify a decomposition reaction is that you're going to start with one compound. Now that compound, such as AB, will be broken up into A and B. When we are going to expect you to predict your own products, we will only give you a single compound, and what we will want you to do is break it up into the individual elements that make up this compound. All right, the fourth type of reaction that we are going to be expecting you to know how to do is with single replacement. And sometimes it is called single displacement, and they mean the exact same thing. So whether you see a worksheet that says single replacement or single displacement, they mean the same thing. And what happens with a single replacement is that an element by itself kicks out an element that's involved in a compound, which therefore makes that element that had been a part of the compound, now it will become an element by itself. So if I look at this general form down here, what I'll notice is that A kicks out B, okay, and B is now by itself, whereas A replaces where B was. When we expect you to predict products, you'll be looking for an element plus another compound. In that case, you will be producing an element plus another compound, okay? All right, then the last type is a double replacement. And with a double replacement, I always consider it like wife swap, where you have one couple and another couple and the wives switch. In this case, in double replacement, what you're going to do is you're going to switch both metals. So if I look at the general form, I have an A with a C. Okay, A is combined with B, and what's going to happen is A and C are going to swap. Okay, so now if I look at it, A is with D, and C is with B. Okay, and how you're going to identify or predict these products is you're going to look for 2 compounds, and you're going to switch the metals of those 2 compounds so that they're now partnered up with a new anion or non-metal. All right, how to identify these is relatively easy. All you have to do is first look for those combustion reactions. Always, 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 always look for combustion reactions. So I'm going to look at number 1, and is it a combustion reaction? Meaning, do I have a hydrocarbon plus an oxygen producing carbon dioxide and water? That is definitely no. After that, what you're going to want to do is you're going to want to write down if it's an element or compound. This guy is an element because it's all by itself. S is an element all by itself, and I'm producing one compound. So if I look at my 5 types of chemical reactions, an element plus an element producing one thing is going to be a synthesis reaction. You may abbreviate synthesis reaction as an S. Sometimes, just to let you know, they also call this a combination. Let's do this in black or blue. A combination reaction, and it means the exact same thing. Typically it is synthesis, but sometimes you'll see a combination. Both mean the exact same thing. So the next one, number 2, I'm going to look for, do I have a combustion reaction? So do I have a hydrocarbon plus oxygen producing carbon dioxide and water? In this case, I do have an oxygen, but it's on the wrong side, and I don't produce carbon dioxide and water, so this is a no-go for combustion. So the next thing I'm going to do is I'm going to label all my elements and compounds. HGO is a compound, Hg is an element, oxygen is an element. So what I notice is that I have one compound producing and breaking up into produce 2 new elements. So what I know I'm going to be doing is it's going to be decomposing. So it's a decomposition reaction. Okay. The next one that I'm going to look at is number 3. And looking at number 3, I'm going to once again check to see whether it's a combustion reaction. So looking at this, I do have a hydrocarbon because I have that carbon and that hydrogen. And then I do combine it with oxygen to produce carbon dioxide and water. So immediately I know this is going to be a combustion reaction. So what you always want to make sure you do is look for that combustion reaction and then go ahead and label elements and compounds. Alright, first what I'm going to want you to do is I'm going to want you to cross off number 4 and rewrite the new formula or chemical equation that I have written down. Alright, so now that I have this written down, as opposed to a repeat of another question that we've already had, what I'm going to want you to do is look for, is it a combustion reaction? Looking at this, I don't have a hydrocarbon, I'm not producing carbon dioxide, water, so I'm done with that. The next thing you want to do is label it. This one, lithium, is an element. COOH2 is going to be a compound, and I produce a compound plus an element. If you look at your identification, I have, of the 5 types, lithium is obviously kicking out calcium to make calcium by itself, and now lithium is a part of the compound. So this would be a single replacement reaction. So what I'm going to do is I'm just going to write SR for single replacement, or you could write SD for single displacement. Number 5, I'm going to look for that combustion reaction. Once again, I don't produce that carbon dioxide and water, so I know this is not going to be a combustion reaction. So I'm going to label this guy's a compound, that guy's a compound, compound, compound. So 2 compounds that undergo a wife swap. So notice that that CD switches with that Na, and now CD is where Na was, so it's hooked up with S, and Na is now where CD was, so it's hooked up with NO3. So I've got 2 compounds producing 2 new compounds, so this would be a double replacement or double displacement reaction, so DR or DD. Alright, I hope you understand a little bit on how to identify the 5 types of reactions. Have a great night.